Hey guys, this is CHEMPLIFIED and today we will discuss or start discussing the chemical properties of aldehydes and ketones. Uh, this is the starting of the video series chemical properties. This is the first part in which we will discuss about the chemical properties of aldehydes and ketones. There will be a series of about 5-6 videos which will talk about only the chemical properties of aldehydes and ketones. So let's start the first video. In this video, we will only discuss the method or mechanism of addition reaction of aldehydes and ketones. In aldehydes and ketones, addition reaction will take place through nucleophilic addition. Now, what is nucleophile? There is a spelling mistake at this place. This is nucleophilic, alright. Double I is there, L will be there in place of one I. Nucleophilic addition reaction. Now, what is nucleophile? Nucleophile is that element or molecule or ion that have the ability to donate electrons now in both aldehyde and ketones, I repeat, in both aldehydes and ketones there is this carbonyl group, that is C double bond O. In both aldehyde and ketone there is carbonyl group which is highly polar in nature. How that is polar? This is your carbonyl group. What happens is either either the electron on the double bond will get transferred to the oxygen like this, or 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 there will be a slight negative charge on oxygen and slight positive charge on carbon due to inductive effect. Why? Because oxygen is more electronegative than that of carbon atom. Now, the positive charged carbon is readily attacked by electron rich nucleophile. Now, we have already discussed that nucleophile is what? That has the ability to donate electron, that can be ion or neutral molecules. Now, electron rich nucleophile will readily attack the positively charged carbon. Why? Because electrons are negatively charged, they will try to find a positive charge. Now the negatively charged carbon is attacked by electron deficient electrophile. Now nucleophile is what? That has the ability to donate electron. Now electrophile is what? That has the ability to gain electron. So here in carbonyl group, this carbon will act as electrophile. So nucleophile will attack the carbonyl carbon, right? Now let's take a look at the process. Now, aldehyde and ketones undergo nucleophilic addition reaction by the following general mechanism. Now, we will talk about the mechanism. The nucleophile attacks the positively charged carbonyl carbon to form a new bond. As the new bond is formed, pi bond between the carbon and oxygen is broken. Since the nucleophile will make a new bond, the bond between the carbon and oxygen, that is the pi bond, will break down and electron pair goes to the oxygen, which now acquires a negative charge. How this is happening? Now this is your nucleophile. What this will do is it will attack the positively charged carbon atom. Since these electrons are attacking the carbon, the pi bonded electrons will shift towards the oxygen, right? The pi bonded electrons will shift towards the oxygen and you will get this kind of intermediate. Nucleophile, this is your two other groups. Now the oxygen will have a negative charge, right? This was the first step. Nucleophile will attack the carbon, the oxygen, the pi bond electron move towards the oxygen. Now what happens next is step 2. The electrophile, for example H plus, attacks the negatively charged oxygen to form the addition product. Any electrophile that has the ability to accept electron will in our case H plus, will attack the negatively charged oxygen atom that has an extra lone pair of electron. It will get that lone pair of electron, and this will give you our addition product. This is your OH. In this case we have got an alcohol. All right. So this is your addition product. This is your addition product. Now, in nucleophilic addition reactions, you can use two different types of catalyst. The first one is base. Now, since you can use two different types of catalyst, first one is base, other one is acid. So there are two different types of reaction in this particular category. First one is base catalyzed reactions. Now what happens in these kind of reactions is, the base help to convert a weak neutral nucleophile to a strong one by removing a proton. So what the base is going to do is, it will remove a proton and the nucleophile becomes a strong nucleophile. The strong nucleophile then adds to the carbonyl group. Let's take a look how this is going to happen. Suppose you have a neutral nucleophile, right? What the base will do is, it will capture the proton and the electron will move towards the nucleophile. What you will get is nucleophile with a negative charge, which is strong nucleophile, and the base will accept the proton, right? Now this nucleophile, now the carbonyl group, if you look carefully, it has a delta positive charge at carbon and delta negative charge at oxygen. So the nucleophile will attack the carbon, and the pi bonded electron between carbon and oxygen move towards the oxygen atom. We have already discussed this process, but the only difference is this reaction is base catalyzed reaction. Now in the similar way, just as base catalyzed reaction, you will have acid catalyzed reaction. Now the process will be completely different. What happens in this case is, the hydrogen ion or the proton from an acid, for example, you have HCl, what this will give is H plus and Cl minus. So the H plus, what this H plus will do is, it will attack the negatively charged oxygen atom. It will attack the negatively charged oxygen atom. So the proton that you have received from the acid, it will attack the negatively charged oxygen atom, and you will get this kind of product. Right? Now the oxygen will have a positive charge. So to compensate with the positive charge, the pi bonded electron will now move towards the oxygen atom. Now what will happen is, as soon as the pi bonded electron move towards the oxygen, right, there will be a positive charge on the carbon. Now what will happen? A nucleophile with just lone pair of electron or with a negative charge will easily attack the carbonyl carbon and proceed with the nucleophilic addition reaction, right? This is the first step. Let's take a look at the second step. Now there is a positive charge, this positive charge is there. Now this nucleophile will attack the carbonyl carbon easily, and you will get the final product as this will be your final addition product, right? This is your final addition product in nucleophilic addition reaction of aldehyde or ketone. This is the general concept for addition reactions. We have not taken any aldehyde or ketone. We have just completed our reaction using the carbonyl group, C double bond O group. We have just taken this and have completed all our reaction. Why? Because this group is definitely present in aldehyde and ketone both. There is a note: the addition product will always be the same whether the reaction is acid catalyzed or base catalyzed. It doesn't matter whether you are going through the path of acid catalyzed reaction or base catalyzed reaction. The addition product will always be the same, right? I hope I made you understand the concept nucleophilic addition reaction of aldehyde and ketone. So this will be it for today's video. Thank you very much for watching.